So let's talk about polyatomic ions. These are ions that have several atoms present with an overall total charge that they all share. You will need to memorize this, and this will take a little more work than the monoatomic ones did because we won't be able to use a periodic table to help us memorize it so well. These ones you will definitely want flashcards and lots of practice. So again, the definition of a polyatomic ion. It is a group of atoms that are held together by covalent bonds which have an electrical charge. The whole group is charged, but the parts of it have covalent bonds. The group had to either gain or lose electrons to get to become a stable octet. That's the only way it will form. And so now it has a charge and it will bond to something with the opposite charge. So polyatomic ions are a single unit and act as if they were a single ion. So while the whole thing says a 2 negative at the end, that means not every single atom has 2 negative charges, but the whole group would be a 2 negative. So let's look at that in the next section. This is the list of polyatomic ions that you need to memorize. Notice that there's only one with a positive charge, and that is ammonium. When we're trying to decide what kind of compounds we have, if we see ammonium, that's NH4+, that one is an indicator that we have an ionic compound. So beware of that one in particular for when we are trying to identify the type of compound. The rest of them all have negative charges. I'm going to give them to you in a small set, so you can read all the names here and you can memorize them all, but I'm going to give them to you in small sets to make it a little easier to help you memorize them. What I expect you to do is to make up all of these flashcards at the same time, and then to take them in small groupings and start adding them to your repertoire. So I'm going to give you 3 or 4 to start with, and then we're going to add another 3 or 4 at a time, and that way it'll help you build up your knowledge. I'm going to give you some of the harder ones first so that you get the most practice with those, and then the other ones come as sets, so we're going to see how that works out. So you'll notice, like here, nitrate and nitrite. They look kind of similar, and so I'm going to put those two as separate groupings so that you can start to memorize them separately. These 4 are some of the hardest ones to memorize, so we're going to start with those. Ammonium, notice it has the IUM at the end of its name, and that's telling us that it's positively charged when it is ionic. A couple of things to note about it. It has 1 nitrogen, 4 hydrogens, and a positive 1 charge. Notice that 4 does not go onto each one of them, so it's just a total of +1, even though it has 5 different atoms present. So that's the ammonium ion. Again, the only one that is positively charged of the polyatomics that we study in this class. Next we have the word hydroxide, and the only reason this one's a little confusing is people like to put hydrogen then oxygen. The formula is O, then H, and then a negative charge. That's the standard form of it. The whole thing has a -1 charge. You need to memorize both the formula and the charge. Next we have acetate, and this one's not particularly hard. It does have a lot of parts to it, but it is easily confused with oxalate. People like to mix those two up in particular. So I'm putting those two into my initial grouping. So we have acetate. It has C2H3O2 and a negative charge, and oxalate has C2O4 with a 2 negative charge. Quite different structures, but they both start with carbon, and neither of them say the name carbon in their name, making them a little more challenging. I recommend you spend about 20 minutes studying those. Just flash over and over and over, making sure you get them. Say out the whole formula because you will be writing the formulas yourself. You don't have to just memorize them, not just recognition, but you'll be writing them out to write the names and formulas of things. So make sure that you're able to do that. And then take a little break, have dinner or something like that. Try it again and make sure that you've got these down without thinking about them. And then you can add in the next grouping. Now, let's add a few more in. So there's 5 of them here, and these are the ones that are the most common ones that we use. We see nitrate with NO3, that's 3 oxygens and a -1 charge. Chlorate, ClO3, again 3 oxygens with a -1 charge. Sulfate, which has SO4 with a 2 negative charge. Carbonate, CO3 with a 2 negative charge. And phosphate, which has phosphorus, oxygen with 4 of them, and a 3 negative charge. Notice that there is no correlation between the charges and the endings on the name. There's no correlation between the number of oxygens present and the charges that are there, but we do see that the name will indicate which element we're starting with. So nitrate has nitrogen, chlorate has chlorine, sulfate has sulfur, carbonate has carbon, and phosphate has phosphorus. Make sure that you spend time studying these for both the number of oxygens and the charge, because in the next grouping we're going to be changing the number of oxygens that are present, but the rest of it will stay similar. That will also change the name of it. Here we can see nitrite and sulfite have been added to the list. So nitrite and sulfite have exactly the same charge as the nitrate and the sulfate, so the same charge, but what we've changed is the number of oxygens. When I go from 8 to 8, it goes down by 1 oxygen, but keeps the same charge. And now I've added in one more, and that's perchlorate. Now perchlorate adds in an oxygen. It keeps the same charge as chlorate, but it adds an extra oxygen in. So the per means add an oxygen. There are actually 4 levels of chlorate to chlorite type of groups, but we only look at chlorate and perchlorate in this class. The one that is more common is chlorate, but we will also be seeing some things with perchlorate. And again, you want to start adding these 3 into your list. Start mixing them in with the other ones so that you can recognize readily the difference between nitrate and nitrite, between sulfate and sulfite, and between chlorate and perchlorate. Be able to write those formulas because you will be writing them on quizzes and tests. All right, so let's add in the last 3. We have bisulfite, bisulfate, and bicarbonate. Notice that they all start with the prefix bi, and you'll notice that in the formula they have the same formula as the second part of the name, so sulfite becomes bisulfite, and they have the formula SO3. That part's all staying the same, but what's different is when I put in the word bi, I add an H plus to it. And what happens when I add an H plus is I put the H at the start, and I lower the charge by 1. So I subtract 1 from the charge, and it becomes HSO3 minus for bisulfite, and SO4 2 minus for sulfate becomes HSO4 with 1 negative for bisulfate, and carbonate, CO3 2 minus, becomes HCO3 with a 1 negative when it becomes bicarbonate. Add those into your list and start memorizing them. Hopefully this will go easily because we're only adding an H plus and the prefix bi to a formula that you already know. Again, lowering the charge by 1. And that's it for all the polyatomic ions that you need to memorize. Next, we're going to talk about how to use them in formulas.